Hello friends, let us do this one more problem on acceleration. The displacement in meter of a particle moving along x-axis, it is given by x is equal to 18t plus 5t square. Now calculate the instantaneous velocity at t is equal to 2 seconds, number 1. Okay, number 2 is average velocity between t is equal to 2 seconds and 3 seconds. Then the third part is instantaneous acceleration. Okay, so instantaneous velocity, average velocity, and then instantaneous acceleration. Let us see how to do this. Now what is the relation here? X is equal to 18t plus 5t square. Correct? We want instantaneous velocity. So we have expression for displacement. For velocity we will differentiate. Okay. So dx by dt is equal to 18 plus 5 into 2, that is 10t, that is my velocity. Okay, now the first part, instantaneous velocity at t is equal to 2 seconds. So in this expression I'll put t is equal to 2 seconds. So that gives me velocity, I'll say at t is equal to 2 seconds is equal to, so that is 18 plus 10 into 2, so that is equal to 18 plus 20 equal to 38 meter per second. So that is my velocity, instantaneous velocity at t is equal to 2 seconds. Now let us go to the second part, average velocity between t is equal to 2 and 3 seconds. So for average velocity, what we should do? There are two ways of doing it. I already have my expression for velocity. Okay, so in this expression I'll put t is equal to 2 seconds and t is equal to 3 seconds. Okay, I'll get both the velocities and then take average of that. So this part 2. Okay, so velocity at 2 seconds I have, so velocity at 3 seconds I'll find. That will be equal to 18 plus 10 into 3, that is equal to 18 plus 30, and 18 plus 30 is 48 meter per second. Correct? So my average velocity V average is equal to 38 plus 48 upon 2. So that is going to be equal to, how much is 38 plus 48? It would be 86 upon 2, that is 43 meter per second. Right? So I have got average velocity, but now I want to confirm whether it really is correct answer. Okay, so for that what I'll do is I'll find the displacement at t is equal to 2 seconds, displacement at t is equal to 3 seconds. Correct? And then what I'll do, I'll add, I'll find the change in the displacement and I'll divide that with change in time. Okay, so again 2 I'm writing here. So x at t is equal to 2 seconds, x at t is equal to 3 seconds is equal to, and is equal to, what is my x? 18t plus 5t square. So 18 into 2 plus 5 into t square. 2 square is 4, so that is equal to something here, and my x at t is equal to 3. So 18 into 3 plus 5 into 3 square, that is 9. So how much is this? This is 36 plus 20, that is 56 meter, and this is 54 plus 45, that is equal to 99 meter. Correct? So I have the displacements at these two. Okay, so my average velocity should be equal to my final displacement minus initial. So my final is 99 minus initial is 56 divided by final time is 3 seconds minus initial time is 2 seconds, that is equal to 43 upon 1, and that is nothing but 43 meter per second. And is it not same as what we got here? So that means both the formulae, they do make sense. Okay, let us move to the third part, average velocity. Okay, now third part is instantaneous acceleration. Now for instantaneous acceleration, what should we do here? Okay, first of all, we had expression for displacement, from that we found expression for velocity, and now we will differentiate velocity, expression for velocity, to get acceleration. So what is the expression for velocity? Is it not 18 plus 10t? So part 3 here, my v is equal to 18 plus 10t. So that dv by dt, 18 is constant, derivative is 0, and then this would be equal to 10 into 1. So that means it is 10 meter per second square. Now here there is one thing to be noted. My acceleration is constant. They have asked you what is instantaneous acceleration. When they say instantaneous acceleration, it should be acceleration at some particular instant. Okay, acceleration at that instant. And surprisingly, they have not specified any instant there, because they already knew that my acceleration is going to be constant. Okay, so no need to specify any particular value for time, isn't it? Now suppose in this problem, instead of giving asking you what is instantaneous acceleration, they would have said instantaneous acceleration at t is equal to 10 seconds. What would you do? You could do the same thing here. You differentiate velocity, and on differentiating velocity you would get acceleration is equal to 10. Okay, no, there is no term involved in, no t term involved, neither t nor t square or anything like that. So you should you can be sure when your expression for displacement has got the highest power 2, then your acceleration is going to be constant. If the highest power is 1, then acceleration will be 0. Time and velocity, they will have a linear relationship. No, the velocity is constant over there, so no acceleration. But then if you have this highest power of t as maybe 3 or more, over there acceleration is going to be variable. Okay, so at time changes, acceleration is going to change, right? So that's all in problems in acceleration here. In the next video, we are going to start with kinematic equations of motion for uniform acceleration. Thank you so much.